Thank you very much. So I will give you a perspective from a small company of how we could use instant JChem as an easy customization to have a very efficient and flexible, yet simple, database for storing biological data. So a little background on the company, just so that you can understand our, let's say, the deliverables we needed from this. So iTeos Therapeutics was founded in 2012, so it's a pretty recent company. It had some decent funding of 3 million capital plus a 6 million grant from the well-known region, but there's still not a lot of money to bring a project or several projects up to IND stage. So that sits a bit the limits of what we could have. We started operations when I basically joined at the beginning of the company. Between September and November 2012, we were starting operations. And in 2012, we were 5 employees. 1 chemistry, 4 biologists, among whom one was was the CEO. So as you can imagine, we had no research informatics team, no IT except a consultant for really when the computer is not working or the network is not working. So we had 3 projects, of which 2 were real medicinal chemistry projects, so generating lots of molecules and generating lots of data for those molecules. Within the first 2 years of the company, we generated more than 1,000 new small molecules on top of having a couple of HTS decks to analyze. That makes quite a lot of biological data we wanted to be able to analyze and store properly. Because of the structure of the company, we had to be very careful, focus our hard-won money on projects and not on capital expenditure. So things like creating the informatic infrastructure was of course not a high priority in terms of how much we could spend on it, but at the same time we wanted to be very professional in how we handled the data. First of all, to inform me as the medicinal chemist on where I needed to go through, but also because of course when you're a small company, it means due diligences from potential investors, from bigger companies, and we wanted to be extremely professional, secure our data in the best way, and use it in the best way. So first thing we did was the implementation from day one of an electronic lab notebook to make sure that we were following up everything we were doing. The most relevant part from this talk is that we need a database to store all this biological activity data, both generated internally and at several CROs. Of course, we couldn't afford to take one of the big existing databases. There are some which are available commercially. They're honestly a bit out of price, at least so far, until ChemAxon is going into there. We needed a fit-for-purpose tool. We couldn't get all the bells and whistles I was used to when I was in Merck. We needed something a bit more agile, but still making the most important thing. So we decided to use instant JChem as the basis for building the database and to use ChemAxon's expertise, because again, no research informatics on our part. I could only give a checklist of what I needed, use ChemAxon to really customize this to be fit for our needs. And to do this even better, I actually team up with another ex-colleague of mine who works at Aseneuron, which is another spin-off, which was generated more or less at the same time, based in Lausanne, and they have very similar needs than us, so we could team up, because, well, let's say 2 heads think better than one, and we could get better product at the end. So we wanted a limited customization with a limited budget at the time, but still fully searchable, not only by structure, but by any kind of data. You want to look for all the compounds with a IC50 below a certain level on a certain project, you must be able to do it by iTeos code, by supplier code, you name it, we wanted to be able to search by anything. Capable of handling data at both the molecule and batch level. We removed the salt level. You could have had 3 levels. You want to only have data on the HCl salt of a certain compound. We only work by batch. It was a decision. And most importantly, having a set of, capable of understanding that there is different type of data, and this data cannot be used in the same way. Some needs to be averaged, some needs to be not averaged, and that is inbuilt into the database. Okay. With being able to both look at individual molecule, what I call it, if you want, an ISIS style view, but also lists of molecule, more of an SAR table kind of view. And easy interfaces with everything else. So I will go first through the compound view, and then we'll look at the list view, but don't forget it exists, because otherwise you think it's an ISIS clone, which it is not. So you recognize on the left part here that you have, well, the usual JChem, let's say, menu where you have different tables. So here is the compound one, opens this thing here, which is marked there. And it's comprised of 5 main parts. You have a part which is really about the compound itself, with the structure, a number of calculated fields, and a number of tailor-made fields like the iTeos code. You have a batch zone where you can look at the different batches which have been made with their individual coding. Then you will have what I call the tabs part, because you will have different tabs, and each of them will activate different type of data which are handled differently. This, for example, is the tab for IC50s. So then you have 2 parts, 2 tables. One is for averaged result, and one is for individual results. And we'll go through each of those. So the compound view and batch view is pretty standard. I don't think that's nothing really interesting there. So you have a iTeos compound code, which is generated by us. The structure, a lot of calculated fields. We're trying to use the full power of Instant JChem. You all know what it can do. You saw it before. I will not teach you again. Then we have a table for the batches. As all tables with Instant JChem, you can decide how many columns you want to see. So here is a pretty crowded view where I try to put all the things which you normally look at. But if you want to have something more visible, you can say, I only want to see some of the columns and toggle them off or on as you want them. And these are all the kind of data which we import linked to each individual batch, which mostly come from the supplier. Our medchem is done externally. Okay, so all fields, like for every other view I will show you, are fully searchable. So if I want to search for a certain supplier code from the supplier, I can and find back then which iTeos code is associated to that, without having to go through the electronic lab notebook or any other tool. For the biological data, a bit more interesting. Again, as I said, we have two tables. Again, the table can be adapted. So you can see here, for example, I have less columns than I have there because some of them are either non-applicable, like the file name, or some are simply not interested at that kind of level. So it's a high-level aggregated view and a detailed view for experiment. What we have mainly is that each data, and maybe this is actually easier to see like that. So here is only the aggregated results view. I've taken the first of these worksheets, let's say, or tabs, which is the dose response curves. So basically anything which becomes an IC50 or a KI or something like that. And for these results, the rule is that there will be an automatic averaging of the individual results. So the system knows it's an IC50, then I will look for the same batch code and the same data type. So is it an IC50 or a KI? Same compound, same batch, and same SOP. SOP is a type of experiment, okay? Determination of A2A antagonistic activity on CHO cells. Then it will average out the results, and this is what I get in this aggregated table. So the averaging is done by the batch of the compound, the type of assay, and the result type. Here I only have IC50s, but you could, for example, report several result types for the same experiment. You report the IC50 and the KI, or you could be reporting, if you have, for example, an allosteric modulator, the EC50, but also the amplitude increase that you have. So you can have for one single SOP type of experiment, different result types. And this is what we had decided at the beginning. We wanted to have a certain flexibility without having to create one different SOP number for each type of results coming out. So one SOP, one experiment, multiple possible readouts. Then what we report normally for each result is the IC50, the amplitude of the curve from 0 to 100, always as a normalized data. And then you have the number of times this experiment has been repeated. So you have actually two types of counts. One is the counts which give an IC50 and a total. The two numbers are only different if one curve doesn't give an IC50 because, for example, it's out of the range. Okay. And for each of these, you can go and look at individual results. These are not aggregated. These are for each compound and each SOP, the individual experiments which have been run. So in this case, for example, on this particular assay, which has this SOP number and this assay title, we have all these individual data from different experiments, and these are all averaged in the table I showed you before. One thing to notice is that we express the results in, well, of course, as a numerical result, scientific notation result, but we have also placed for a modifier, so that if you have something which is more than 10 micromolar, we can actually indicate both the number and the modifier. We also store for individual results the data of single point concentrations. Typically, we only record the highest and lowest possible concentration as a kind of sanity check against, let's say, an extrapolation of IC50, which doesn't bear with the real result. But you could easily customize this if you wanted to actually database record every single point to be able to retrieve all the curve as a data handling tool. You could easily do it and then just toggle them off the view, not to clog the view with that kind of data. Each experiment, is linked to an electronic lab notebook number so that we can easily link to the ELN. Now, ideally, I would have liked a system where everything is integrated. I could click into it. But again, limited budget, small company, we have to accept compromise. It's very easy to accept the fact that I just have the number here and I need to type this number into my ELN. Another very nice feature is that I have, I have a direct link. If I hover with the mouse over this column, I actually get the link to the PDF of the actual curves of the extrapolation. Again, ideal world, you could like to link this to the software which has actually created the curve, but for us it's good enough that we can see. And if you are looking at this compound is interesting, you might want to check the curve of a particular experiment to see maybe why it's different than the other ends that you have generated. So as I said, we have different, what I call masks. These are different worksheets for different type of data. So we have one for dose response curves. We have one for biological results at one concentration. We have one for basically physical properties or anything which can be described by one number and one unit of measure. We have one for microsomal stability, one for permeability, another for irreversible parameters like irreversible inhibitors, innate kinetic parameter, one for PK in vivo, one for pharmacodynamic in vivo, and another for analytical data. The reason we created this is because on one hand, some of these worksheets have different rules for handling data. I'll show you later the one for in vivo PK, for example. We don't do averaging of results. Another reason is that here for microsome stability, for example, we could have worked on it on the same rules of the dose response curve by simply having different type of readouts. The question is, it's something that I use so often, I don't want to have clearance for human, clearance for mouse, each having where I need to find different combinations of readout and SOP number. I prefer to directly have a worksheet which explicitly gives me what I need. The in vivo PK one, for example, is a typically different one where not only I have a large number of data fields which I want and I want to be able to define, so it finds all the right ones, but as a different type of ending of the results, we don't have averaging in this case. So when I look at in the table view we'll see later, I want to retrieve PK data, it will concatenate all the data and it will not average them. So this is embedded into the system. I will show you later that you have a definition of each of these masks, and whenever I generate a new SOP, I can tell which type of data is generated, so it sends it to the right mask using the right averaging rules. This is the other view. It's a traditional table or SAR view. So in this case, for example, in light blue, you can see that I had searched for a particular substructure. These are the compounds which came up. It's a bit boring because it's always the same compound in different batches. The problem is I couldn't show you many other compounds in our database because of confidentiality. But it's important to notice that indeed the SAR table is still based on batches because it was a decision we made consciously at the beginning. We didn't want to average results among different batches, so then we treat each batch of a compound as an independent entity. That's the basis of our data aggregation. So of course you will find all of them here. There are of course very easy ways. If you want to remove that, you can couple the search with looking for only batch ones in the iTeos code. So you can, if you don't want to see all the batches individually, you can easily do it. And again, you will be able to select which columns you want to see, which data, and then I will not go again through all that Instant JChem can do, but starting from there is a lot of tools that you can use in Instant JChem, visualization tools, filtering, exporting, etc., linking to the other tools of the ChemAxon suite. So that's a very easy to use system, let's say. Here I want to show you the assay and experiments view. So these are other options you can choose to basically have a look at what you have in your database. So here you will see that for each SOP number that you have, as I said, you will have a title that explains which assay we're talking about, and then the result table is what links it to the right mask and tells it which type of data we have available. So it's extremely simple to actually create a new SOP number because you have a new project or simply a new assay of an existing project, and you can add it there. You put there the number, you put a new SOP unique number, and you tell which table you want to do. Then you have to just go into one script when you have for the formation of the table to tell it, you have to also look for this SOP number when you create your table. So that's the advantage of we started as a 5-people company with 2 projects. We are now a 40-people company with 7 projects, and I didn't even have to actually go to ChemAxon to ask to change the system. The system is flexible enough, it has supported us in our growth without needing not only ChemAxon, but even an experienced IT person, because honestly, I'm only an end user and I'm pretty uncivilized compared to computers. I'm a very simplistic user, and still I can use this and expand it to suit our needs. And then we have a view for experiments. So each experiment which is created will be stored, so I can easily see exactly which experiments are loaded in the database. And each experiment of biological data experiment is identified by a lab notebook number and an experiment date. And with this, we have a one-to-one relationship with data we find in the database. The other thing, so how do I load the data that I've shown you? Again, it's extremely simple. It's all done by a simple Excel table. So for each one of these masks, I have a different table because, of course, I need different data fields. These have been preset. This is, for example, the table we use for IC50 determinations or any KI, any type of data which goes into this first worksheet. So the biologists can easily create them starting from the tools they use for curve fitting, and then we can just load them. And as I said, adding new SOPs is extremely easy, as shown in the table before. The only thing which would be complicated is if we had a new type of data for which we need a new mask, which with different rules for averaging, for showing the data. That's the only operation which would really need ChemAxon's intervention and really go into the scripting of the system. Loading compounds is also extremely simple. Well, again, that's pretty standard. It's the way you work if you use instant JChem. So we start from an SD file, which comes from the different suppliers, which have the data which they need to populate. Then there is a stage worksheet within instant JChem, where we import from the SD file. It will automatically recognize the columns if they are called in the right way, so the data will go into the right positions. Otherwise, you can manually map them so that you instead of purity %, the supplier said just purity, you can just map them manually. The system has a nice safety feature, let's say. So that once you put the compounds in the stage, you get something like this. Again, it's a bit small, difficult to read, but you have the structure there, then you have the iTeos code, and then all the data that they have generated. I can check them visually. Then you have a register button there. Now, if the system recognizes that the compound is already present, but you have given it a different iTeos code, then we'll say, look, there's a problem. This should be a new batch. It's not a new compound, and it asks me to correct the error. It has a fairly solid system for stereochemistry, as you know, for instance, JChem. So I never had problems into loading a new structure and having a unique entry for it. So in conclusion, instant JChem has been easily customized to create a system which stores and handles efficiently biological data. It can be adapted to different needs, from a very, very small company to one which is growing up. It's pretty flexible. It maybe doesn't have all the connectivities that I used to have in Merck, but it has most of them. And honestly, the only things that are lacking is things where you need to do a copy-paste of something instead of clicking on one button. It's really not a big deal. It's really easy to maintain for a customer point of view. And we are already looking at the next step. We are now starting biologics projects, antibody projects. So this is, of course, set up for small molecules, and we are eagerly working with ChemAxon to implement also the biologics handling system into this, which will be the next step for our company to be able to store all our biological data. And I would like to finish off by thanking, Anna Quattropani and the team at Neuron, because they were equally stakeholders as us into creating this, and they also have been using for the last 4 years. And at ChemAxon, Tim and Daniel were the ones who did the implementation for us. Fred has been really, really helpful. The only one time where I created a problem in the system by corrupting a data field. And all the members at ChemAxon for all the support, and especially now the people working on the biomolecule toolkit, because we'll be working together to do the next step for us. And thank you all for your attention.
In the case of aggregated results, is there? I had the feeling that you have all the batches present at the same time on your page.
Yes.
Is it possible to have a dynamic link between the part of the page where there is batches information? You click on the batch, you obtain only the batch, the results of this batch.
So this is one of those, let's say, nice to have things which I would have loved to have, but at the time when we were really, the thing was all customized for us, I couldn't ask for additional hours of customization just to implement these kind of things. So I'm pretty sure that now this is, pretty straightforward to implement from a practical point of view. Maybe somebody from ChemAxon can answer that better, and that, if ever this becomes, in what it would be an off-the-shelf product, it would certainly be like that. For us, it was not a necessity, and we had really to make, hard compromises on what was necessary and what was a practical thing to have. So we didn't do it, but I'm certain it can be done.
Okay, and another question, sorry for that. I saw also that individual results, you have a checkbox which is able to be checked if there is some invalid results.
Yeah.
Do you dynamically change the average value which is integrated into the aggregated results?
I believe so. To be honest, I've never used it, because once we validate the results before loading them, so I would not load myself a data which is invalid. I would rather put, so that's never happened, to be honest. But yes, I'm pretty sure, if I remember from 2 years ago, that if you modify that, the average will change.
Okay, and last question. You have the possibility to put a qualifier information into
Yes.
the individual results. Do you, sometime when you have different batches, you can, different results for batches, it's possible that 3 are exact value and 1 is with a qualifier. Do you exclude this value with a qualifier for the average?
It's a situation where there is no perfect solution indeed. If you use it for the average, we use it without the qualifier. So if you have 9, 9 and more than 10, it will average between 9, 9 and 10. But I still feel that it's more closer to reality than averaging only 9 and 9. So of course it's not perfect, but whenever you have a more than something or less than something in an average, you have a mistake, you have an error, right? Because you have not been able to measure correctly. So we keep it in the average without the qualifier, and that's one of the reasons why I like to be able to see individual results at a glance. Indeed, because whenever I have an average which is close to the edge, I can see if there was a qualifier in one of the data points.
Because something which is easy to do is to exclude this specific value and do a difference between the total count and the average count.
It was a decision from us. Again, if you have 9, 9 more than 10, what's more close to the truth, 9 or 9.3? To me, it's 9.3. So it's just a decision as an end user that I prefer to count it in rather than not.
Yes, but more than 10 can be 30.
Yeah, but that's still 9.3 will be closer than 9. So by removing it from there, you will have you will skewer the average even more, but it will do what you say. The counts will be differential. If you have 9 more than 10, you will have a count of 2 and a total count of 3. So again, at a glance from the line, you will know that one of the data points which was used for the average had a qualifier in it.
Okay. The last one, sure, sorry. When you did the import of data, you told that the mapping of column is not a problem, and is it case sensitive or not?
In the Excel sheet, I don't believe it is. I don't believe it's case sensitive. I would have to double check because again, you use always the same ones, but I don't believe it's case sensitive. I can check.
The first 2 questions from before, these are just configuration settings. So if you need to solve those, feel free to approach us and we can do a simple script for the first one and a simple configuration change for the second one. The averages can be, of course, performed on the fly. We can do this through our calculations and scripting support. And I forgot what I wanted to say as the last step. Anyway, my question was, what are you actually missing from instant JChem?
Right now, again, in terms of what is really absolutely necessary from a small molecule perspective, this is perfectly fit for purpose for us. There are indeed a couple of nice things where you say, okay, can we link to other things? For me, the main thing right now is really the next step is to be able to handle biologics in the same way, because it would really simplify our life. Our, let's say, screening groups or biologists, those who generate the data, have now gotten used finally to using an Excel file to load data. And I certainly don't want to have a second different way to load biological data for biologicals. So I would like to be able to use a system which is as close as possible to this one for the biologicals, which we will have pretty soon. And other than that, honestly, it's already probably being able to do even more than I'm simply able to exploit. So I'm probably only using the system at 30% of its capacities. So that's my bottleneck. It's not the system. I will be there for half an hour after if you want.
No, I forget one. In the in vivo data, maybe I didn't see it, but I do not see any information on gender information for male or female, and I think it's very important.
It is. It should be there actually. I think it is there. There is many columns. I probably have toggled off a few of them just to be able to see it. It's a very information heavy type process because for one experiment we generate a lot of data. There is a lot of free text fields also linked to that. So, but I agree that it's an important information.